One of the most recognizable long-range strategic bombers in aviation history, the B-52H Stratofortress, is a tribute to the engineering skill and versatility of the United States. The B-52H, which was first deployed in the 1950s and has since undergone several upgrades, continues to serve as the foundation of the strategic bomber fleet of the United States Air Force. The aircraft's internal configuration, avionics, performance, and systems reflect decades of improvement targeted at endurance, durability, and mission flexibility, even though its primary duty is military rather than passenger transport. Number 1. Cabin configuration and design. Instead of being comfortable, the B-52H's cabin is functional and designed for combat missions. The pilot, co-pilot, and electronic warfare officer are located on the top deck, while the radar navigator and navigator are located on the lower deck. The cockpit and crew quarters are organized on 2 levels. A thin internal ladder provides access between decks. Instead than focusing on ergonomics, the design prioritizes usefulness and survivability, optimizing space for instruments, controls, and mission-specific equipment. Because of the large avionics and mission equipment, the cabin seems small and crowded despite the aircraft's size. Number 2. Interior materials and finishes. The inside is constructed to endure long-term operating wear and is made of sturdy, fire-resistant materials. Insulated wire bundles, reinforced composites, and exposed metal panels make up the majority of the surfaces. For long trips, seat cushions are coated in sturdy, flame-retardant fabric. The design places more emphasis on simplicity of maintenance, thermal insulation, and resilience to vibration and acoustic stress than it does on beautiful finishes within. Number 3. In-cabin entertainment and connectivity. The B-52H has no passenger connection or entertainment features because it is a military aircraft. Instead, its entertainment system is replaced by advanced communications and electronic warfare equipment. Crew members depend on secure satellite communications for worldwide connectivity, mission computers for data input and monitoring, and intercom systems for collaboration. To provide mission awareness and coordination over long distances, modernized B-52Hs are equipped with digital communication suites that can exchange data in real time with command centers and other aircraft. Number 4. Noise reduction and cabin environment. The B-52H's 8 Pratt & Whitney TF33P3 turbofan engines and its unpressurized, thinly insulated fuselage portions are the main causes of its very high interior noise levels. Despite advances in insulation, the cockpit is still somewhat dry and noisy, thus crew members wear oxygen masks and noise-canceling headsets while in flight. Although temperature control systems keep the environment habitable, functioning comes first. The bomber can safely operate at high altitudes for lengthy periods of time because to the environmental management system, which provides heating, restricted cooling, and pressurization for the inhabited portions. 5. Cockpit and avionics. The Commercial Engine Replacement Program (CERP) and Combat Network Communications Technology (CONECT) modifications are 2 of the most notable modernization initiatives for the B-52H's cockpit. Digital displays, multifunction screens, and integrated mission management systems have either supplanted or enhanced analog gauges. GPS navigation, sophisticated radar systems, and secure data communications are examples of modern avionics. Using advanced sensor arrays, the electronic warfare officer controls radar jamming, threat identification, and countermeasures. The operational usefulness of the aircraft has been extended well into the 2050s because to advancements in automation that have decreased crew effort and improved mission precision. Number 6. Advanced safety features. Despite being older than contemporary fly-by-wire systems, the B-52H has emergency power units, numerous hydraulic circuits, and redundant control systems for dependability. The crew compartment is built for ejection seat evacuation up to certain altitudes and speeds, and the aircraft's construction is strengthened to withstand battle damage. Improved weather radar, terrain awareness, and collision avoidance are all benefits of updated avionics. Radar warning receivers, flare and chaff dispensers, and electronic countermeasure pods are examples of defensive systems that guard against air-to-air and surface-to-air threats. Number 7. Performance and efficiency. The B-52H, which is powered by 8 TF33 engines, can reach a maximum speed of around 650 miles per hour, Mach 0.86, and it can fly more than 8,800 miles without refueling. Because of its 50,000-foot service ceiling, it can function over the majority of danger and weather envelopes. Modern replacements under the re-engining program will significantly increase fuel efficiency, lower pollutants, and increase operating range, even if the TF-33 engines are efficient for their time. The bomber's enormous payload efficiency is demonstrated by its capacity to carry up to 70,000 pounds of ordnance, including conventional, nuclear, and precision-guided weapons. Number 8. Exterior and aerodynamics. With its 185-foot spread wings and large vertical stabilizer, the B-52H has a distinctive look and was designed for long-haul, high-altitude flying. To enhance longevity under prolonged load, its airframe uses a combination of structural reinforcements and aluminum alloys. The design's remarkable range is a result of its narrow fuselage and high aspect ratio wings, which preserve aerodynamic stability despite its enormous size. Radar resistance and performance are further improved by contemporary enhancements, such as wing changes and sophisticated coatings. Number 9. Baggage space. Internal space is nearly entirely devoted to mission equipment, crew systems, and weapons. There is no conventional luggage compartment. The crew has limited personal storage, usually for modest personal belongings, meals, and survival supplies. The internal bomb bay, often known as the aircraft's payload bay, is designed specifically to carry weapons, not supplies or cargo. Number 10. Cost of ownership. Operating a B-52H is substantially more expensive than flying a civilian aircraft of similar size, owing to its military equipment, maintenance needs, and specific crew training. Annual operational expenses per aircraft can surpass tens of millions of dollars, including fuel consumption, maintenance cycles, and mission-specific improvements. However, the platform's longevity, more than 70 years of continuous service, makes it one of the most cost-effective strategic assets in military aviation history. Planned re-engineering and avionics improvements will lower operational expenses and prolong the aircraft's service life into the 2050s. Thanks for watching. Please subscribe to our channel.